Hello everyone, myself Ankur Patel, and today we are going to start a new topic of this subject which is very important, and it is named as engineering course. So in this first session of engineering course, we are going to discuss three different topics or three basic topics of this chapter. One is introduction of engineering course, in which we will discuss what are curves and importance of the curves. Then after we will discuss classification of the curves, and after discussing the classification of the curves, we will discuss about the conical curves, or also known as conics, in which we will discuss definitions and applications of different conical curves. So let's start with the introduction of engineering curves. So what is curve? We can say that when a point gets deviated from its straight line path, then the locus generated by that point is known as curve. So what are the importance of the curves in our day-to-day life? Engineering curves are useful by their nature and characteristics. Some of the laws of nature when represented on the graph gives us curves. In space technology, these curves are used for deciding the path of space vehicles, or we can also say that it is used to define the projectile motion of the particle. In general, these curves are very useful in engineering, in understanding laws, in manufacturing of various items, in designing the mechanisms, in analysis of forces, in construction of bridges, dams, in construction of buildings, water tanks, and in understanding the electric power, etc. Now let us see the classification of the curves. So curves are classified into conics, spiral, cycloidal curve, involutes, and helix, where conics are further classified into triangle, circle, ellipse, parabola, and hyperbola. Spiral are further classified into Archimedean spiral and logarithmic spiral. Cycloidal curves are further classified into cycloid, epicycloid, and hypocycloid, where cycloid is further classified into inferior trochoid and superior trochoid. Epicycloid is further classified into inferior epitrochoid and superior epitrochoid, where hypocycloid is further classified into inferior hypotrochoid and superior hypotrochoid. Let us see involutes. So involutes are further classified into involutes of circle, involutes of line, and involutes of polygons, where helix doesn't have any further classification. So let's move on to conics. So first of all, what are conics? In simple words, we can say that conics are the section of the cone. So first of all, let us understand the terminologies of the cone. So here we have represented a right circular cone. So this point of the cone is considered as the apex point. Then after this, the line joining the apex point and the center of the base, or we can say that an imaginary line joining the apex point and center of the base, is known as the axis. Then after generators, we can say that generators are also an imaginary line connecting the apex point and periphery of the base. So this will be our base. Now if you are taking this angle theta, so this angle is the angle made by generator with the axis, and this angle, which is 2 theta, it is known as aperture angle of the cone, and we can also say that this is the maximum angle between two generators of the cone. So if this cone is cut by a cutting plane, if this cone is cut by a cutting plane at different positions with reference to the base and axis of the cone, then the curve of intersection are known as conics, and the different curves of intersections are triangle, circle, ellipse, parabola and hyperbola. So we can say that triangle, circle, ellipse, parabola, hyperbola are conics. So now let's discuss that when we will get triangle, when we will get circle, ellipse, parabola and hyperbola as a intersection of the cone. So let's start with the triangle. So if you are taking a cutting plane to take the section of the cone, then when a cutting plane contains the apex point of the cone and it cuts the base of the cone, then the curve of intersection will be a triangle. As you can see that this is a cutting plane and it contains the apex point of the cone, it cuts the base of the cone. So here we can see that the curve of intersection is a triangle, and we can say that it is an isosceles triangle. So now when we will get a circle as a intersection, so let's see circle. So if this cone is cut by a cutting plane parallel to its base or perpendicular to the axis of the cone, then the curve of intersection then is a circle. So here you can see that this cutting plane is parallel to the base and perpendicular to the axis. So we get the section as a circle. So now when we will get the cutting plane or intersection as an ellipse. So when this cone is cut by a cutting plane inclined to the axis at an angle less than theta, or we can say that when a cutting plane is inclined to the axis and cuts all the generators of the cone, then the curve of intersection will be an ellipse. So if the cutting plane is inclined to the axis such that it cuts all the generators of the cone, here it cuts all the generators of the cone, then the curve of intersection will be an ellipse. Or we can say that if the cutting plane is inclined to the axis at an angle less than theta, then the curve of intersection will be an ellipse. Theta is the angle made by generator with the axis. Okay, so in case of if you want to find out ellipse, the inclination of the cutting plane should be less than theta. Now when we will get parabola as a section, so when the cutting plane is inclined to the axis at an angle equal to theta, or we can also say that if the cutting plane is parallel to one of the generator of the cone, so this is the generator, so if the cutting plane is parallel to one of the generator of the cone, then the curve of intersection will be a parabola. So here you can see that right now the cutting plane is parallel to one of the generator, so we have get the intersection of a cone as a parabola. Or right now we can also say that right now the angle of the cutting plane is equal to angle theta. Okay, now let's move on to next. So when we will get the hyperbola as an intersection of the cone, when the cutting plane is inclined to axis at an angle greater than theta, then the curve of intersection will be a hyperbola. So if we take the cutting plane inclined at an angle more than angle theta, then the curve of intersection will be a hyperbola. And if we are taking this cutting plane parallel to the axis of the cone, then the curve of intersection is a hyperbola. So these are the intersection of the cone. Now let us move on to definition of the ellipse and its application. So ellipse. So ellipse is a curve traced out by point moving in a plane such that the sum of its distances from the fixed points will remain constant and equal to major axis. So all these terms that are the fixed points and major axis that we will discuss in our upcoming lectures. Right now just recite the definition. So ellipse is a curve traced out by point moving in a plane such that the sum of its distances from the fixed points will remain constants. Now what are the applications of the ellipse? Ellipses are used to design the shape of a tank in a tanker. So you can see that here is a petrol tanker or milk tanker or water tanker. So to design the shape of this tanker, ellipse is used. Next is it is also used to design the structure of the bridge and arcs. So you can see in this figure, to design the arc of the structure of the bridge, we can use the elliptical curve. Now it is also used to design the elliptical gears. So these are the elliptical gears, and if you want to design the tooth profile of this gear, then curves are used. Now it is also used to design or to define the path of the earth around the sun. So here you can see that this is the path of the earth moving around the sun. So this path will be an elliptical path. Now let's move on to definition and application of the parabola. So what is parabola? So parabola is a curve traced out by a point moving in a plane such that its distances from the fixed points will remain constant. Let us see the applications of the parabola. It is used in motor car headlamp reflector. So it is used to design the motor car headlamp reflector. So here you can see that this is a lamp reflector of a motor car or a bike. It is also used to define the sound reflector and detector. So it is the sound reflector or detector you can see in the figure. It is also used in construction of bridges and arcs. So parabola is also used to construct the arcs and bridges or structure of bridges in building constructions. Parabola is also used to define the path of any particle thrown in the air at any angle. We can say that projectile motion of the particle thrown in the air. So parabola is also used to define the projectile motion of a particle thrown in the air. Here you can see the examples of the parabola. So here you can see that if an object is thrown in the air, the path followed by that object is a parabola. Here you can also see that the path followed by the parabola. Now let's move on to next one, definition and application of the hyperbola. So what is hyperbola? Hyperbola is a curve traced out by a point moving in a plane such that the difference of its distances from the fixed points will remain constant. Let us see the applications of the hyperbola. Hyperbola is used to define the graph of Boyle's law. So here you can see that the PV or pressure versus volume diagram of the in the Boyle's law. Next is it is also used to define the shape of overhead tanks. So you can see that hyperbola is used to define the shape of the overhead tanks. It is also used to define the shape of the cooling towers. So here in this video you can see that this shape is a cooling tower. Now let us summarize the applications of the ellipse, parabola and hyperbola. So here in this table you can see all the applications of the ellipse, parabola and hyperbola with the drawing methods. So let us just take the overview of the drawing methods of ellipse, parabola and hyperbola. So we have a total 5 methods to draw ellipse. One is oblong or rectangle method, second is ellipse in parallelogram, concentric circle method, arc of the circle method and directrix focus method. Methods to draw the parabola, one is rectangle method, parabola and parallelogram, tangent method, directrix and focus method. And these are the methods to draw the hyperbola. So first method is rectangular hyperbola, oblique hyperbola, hyperbola with foci and vertices method, and hyperbola with directrix and focus method. So this is it for today. Thank you for watching. In our next lecture, we will go through the methods of drawing ellipse. Till then, take care.